Alright, now we're going to look at the other option in 10.5, which is problems involving the idea of not. This is, again, another indirect way of thinking. So sometimes it is easier to start by counting the ways that an event would not occur. So this is an indirect way to find our answer. So let's recall from Chapter 2 that if any set A is in the universal set, we have the following. So we're going to draw a Venn diagram, and we're going to say that if A is in the Venn diagram, that what's outside of A, inside of U, we called A prime. Remember, A prime is what is defined to be not in A. It's true to say that A plus A prime makes up U. So we have this complements principle of counting that we can now draw from this picture. Right? So it says here that this could be n of U. The size of U is all of A plus all of A prime. Now in the end, what we're really interested in is what's in A. But for some reason, I can't just go after it and count it. But what I could do is I could say the size of A is found by taking all of U minus the size of A prime. If I count the whole box and I take away what's outside of A, I'd be left with what's in A. So here's how you want to think about these for 10.5. N of A equals N of U minus N of A prime. Here's what you want to think. This is what I want. U is every possible way, no conditions. And A prime is what I don't want. And we're going to learn with these problems that sometimes it's easier to find it all and take away what doesn't work to come up with our answer. All right, let's try an example here. If you roll 2 fair dice, in how many ways can you obtain a sum of at least 3? Now you might look at that and go, well, how do I know that's a not problem? This is a not problem because of this phrase, at least. That's a clue to you that you need to make this an AU, A prime problem. So what I do first is I write in words what each of these letters represent for this problem. So remember, A is what I want. So I want a sum of at least 3. U is everything that happens when you roll a pair of dice. All possible sums. And A prime would be what does not satisfy A. So if A is a sum at least 3, A prime would be a sum less than 3. Then I know my formula says N of A equals N of U minus N of A prime. Well, how many total possible sums are there? If there's 6 numbers on one dice and there's 6 numbers on another, my product table that we looked at earlier in Chapter 10 would tell me there are 36 total possible sums. minus, well, how many ways can I get a sum less than 3? Well, the only way to get a sum less than 3 is to roll snake eyes. 1 and 1 would be a sum of 2, so there's only one way. So my answer here is there are 35 sums that are at least 3. All right, let's try again. A Civil Air Patrol unit of 10 members includes 4 officers. In how many ways can 4 members be selected for a search and rescue mission such that at least one officer is included? So again, it's an A prime problem because of this phrase, at least. A is what we want. So we want, in how many ways can 4 members be selected with at least one officer? So we want 4 members selected at least one officer. U is any 4 members selected. A prime is 4 members selected no officer. Because if you need at least one, no officers wouldn't satisfy that. So I think it's helpful to write in words what AU and A prime represent. Now I'm going to use my formula. N of A equals N of U minus N of A prime. Now remember, we're still in Chapter 10, and we should still be asking ourselves those key questions. Does order matter? And is repetition allowed? Well, remember, key word here, you are selecting. If you are making a selection, order does not matter. But it also implies that repetition is not allowed. You need 4 members. You can't have the same person represent 4 different people. It has to be 4 different people. So to do the problem, it's going to use combinations. Now, N of U is any 4 members selected from everybody who's eligible. So they say there are 10 members. So this is 10C4. Remember, all 10 are eligible. I need 4 where order doesn't matter and repeats aren't allowed. Minus, A prime says I still need 4 members, so it's still a combination choosing 4, but now I cannot include the officers. Well, they told us that there were 4 officers, so my 10 is now down to 6 because I cannot include them. If I punch this in my calculator, I get 210 minus 15, which is 195 ways. So 195 ways is the answer to A. How many 4-member selections will include at least one officer? All right, 9. Find the number of 4-digit counting numbers containing at least 1 0 under each of the following conditions. First, repeated digits are allowed. So let's do A prime, because I see the phrase at least 1 0. So A is 4-digit counting number at least 1 0. U, all 4-digit counting numbers. A prime is 4-digit counting number Remember, the general job doesn't change as you're finding A, U, and A prime. It's the condition that changes. So now the condition is A prime. So we would want 4-digit counting number no zero. Now A specifies that repeated digits are allowed. So we're going to do n of A equals n of U minus n of A prime. Now repeats are allowed, so remember, if you're repeating, permutations and combinations are off the table. They are not allowed. So this is straight up FCP, 4 dashes, a dash for each placeholder in our number. So U is all 4-digit counting numbers, so I can't start with 0, and every other spot can have any number 0 through 9, A prime is still 4 dashes because it's still a 4-digit counting number, but now the condition is 0 isn't allowed anywhere. So 9, 9, 9, 9. So if you work that with your calculator, you get an answer of 2,439. Now how does B change it? B says repeated digits are not allowed. So that doesn't change A, U, and A prime. They're the same. But it does change our numbers that we are allowed to write on our dashes. So n of A equals n of U minus n of A prime. So this is still 4 dashes because it's still a 4-digit number, but repeats aren't allowed anywhere. So I like to start in the front and acknowledge that 0 can't go in the front. Now I'm not allowed to repeat. So something used here is not allowed to be used anymore, but 0 gets to be included again. So that's why that's still 9. And then I start counting down 8, 7. Minus, to find A prime, I still have 4 dashes because I have a 4-digit counting number. But remember, the condition on A prime is no 0. So I know that I couldn't ever use 0 in the front. And they said I'm not allowed to use 0 anywhere, in fact. So now 0 doesn't get kicked back in like it did before. So this is just counting down straight up originally from 9. So if I do my calculator work, I get 1,512. All right, number 10. A school choir has 5 sopranos, 7 altos, and 6 baritones. In how many ways can the choir director choose a quartet with at least 1 soprano? There it is, at least. That means A, U, A prime. A. How many do we want in our choir? We want a quartet. So quartet, at least 1 soprano. You might wonder, well, why do we keep doing it where we find out what doesn't work in subtracting? It's because if you think about all the ways it can happen, there's a lot of work. Quartet at least 1 soprano means a quartet with 1 soprano, or quartet with 2, or quartet with 3, or quartet with 4. So you'd have to find out all of those ways independently and add it together. Far faster to figure out what does not work. If you're not sure, quartet means 4 people. U is all quartets. A prime is a quartet, no soprano. So we want to do n of A equals n of U minus n of A prime. Now choose. Choose means that we get to make selections. So what does selecting mean? It means order doesn't matter and repeats aren't allowed. So it sounds like combination to me. So this is C4 because I need a quartet. Now U is all quartets, all singers in the choir could be chosen from. So we add 5, 7, and 6, and we get 18 people in the choir. Now A prime says a quartet, so I still need 4, but I cannot look at the sopranos. So I'm going to take out the 5 sopranos, and I'm going to look at the other 13 singers. I'm going to punch these in with my calculator and subtract. I get 2,345. 11. Three friends board an airliner just before departure time. There are only 11 seats left, 2 of which are aisle seats. If you may sit anywhere, how many ways can 3 people arrange themselves in the available seats so that at least one of them sits on the aisle? Some key words here. We're going to talk about arrange, and we see at least one. So this is A, U, A prime. A is arrange 3 people at least one aisle seat. U is arrange 3 people. A prime is arrange 3 people, no aisle seat. Alright, so this is N of A equals N of U minus N of A prime. So U, arranging 3 people. Okay, now we're going to talk about that. Arrange. That means order matters. It also means that repetition is not allowed. So it is a permutation. We need to sit 3 people down where order matters. Well, how many seats are there if it's U is arrange them in any seats available? 11. So 11 P3. Minus A prime is arrange 3 people. So it's still P3. But no aisle seat. Well, how many aisle seats did it say? It said there were 2 aisle seats. So those are off limits. We can't use them. So that makes our 11 become 9. We do our calculator work and we get 486 is our answer.